Good afternoon and welcome to today's T&D World webinar titled Behind the Scenes of Skipjack Solar, How Fiberglass Conduit Powered a Fast-Track Solar Project, sponsored by PDI Squared and Champion Fiberglass. I'm Nikki Chandler, I'm Group Editorial Director for T&D World with Endeavor Business Media. To begin, let me explain how you can participate in the presentation. First of all, if you have any technical difficulties during the session, please submit to the questions window and our technical experts will help you out. We do recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with that webinar player. Additionally, we do welcome your questions during the event today. We'll answer as many questions as possible throughout the webinar and during the Q&A session that follows the main presentation. But please feel free to send in your questions at any time so that our moderator can see those and get to those as soon as possible. To do so, simply type your questions in that question window on the side of your screen and hit submit. Also, please be aware that today's session is being recorded and will be available on the T&D World website within the next 24 hours. You will be notified by email when that archive is available. Now, I would like to introduce our discussion moderator. Mike Beeler is the National Spokesperson for the Power Delivery Intelligence Initiative. So welcome, Mike. Please go ahead.
Thank you very much, Nikki. It's a pleasure to be here on this really interesting topic of fiberglass conduit, and we're thrilled to be here. The Power Delivery Intelligence Initiative is a group of contractors, consultants, manufacturers of things like fiberglass conduit, and equipment manufacturers that advocate for planners and engineers and even data scientists these days to take a good close look at underground when looking at major projects. And we want engineers and planners and data scientists to evaluate the total cost of ownership of underground versus overhead over the life of the asset. And today, we're going to talk about fiberglass conduit with one of our members of the Power Delivery Intelligence Initiative. And with us is Matt Fredericks of Champion Fiberglass. Matt, say a quick word of hello for us, if you would, please.
Hey, thanks, Mike. Like Mike said, my name is Matt Fredericks. I'm the Director of North American Business Development for Champion. Been with the company about 4 years and actually represented Champion as a utility rep in the upper Midwest for 6 years prior. So have a good familiarity with the company and the product, and really looking forward to having a dynamic discussion today.
Well, we're looking forward to it as well. Matt, I shared with you, and I know I posted this on LinkedIn, that 40 years ago, one of the things that I did at Tucson Electric Power was build underbridge conduits out of fiberglass. And we looked at all the attributes of fiberglass and how are we going to get our underground system through this bridge, and working with the DOTs and everything like that. And so here we are now, literally 40 years later, Matt, and we're going to have a great conversation about some of the attributes of fiberglass and how it makes a lot of sense. So really looking forward to this conversation, and it will be a conversation. Audience, you are welcome to send in your questions at any time, and Matt and I are going to talk about it, and if you got a really great question, we'll try to get to it straight away. Otherwise, we'll have Q&A at the last about 15 or 20 minutes, and then we'll wrap up at the top of the hour. So Matt Fredericks from Champion Fiberglass, are you ready to take it away?
I am, Mike. Thank you. And to Mike's point, just before I speak, one thing I hope that you all take from this presentation today is that fiberglass can be used for many, many different applications beyond just underbridge use. That's where we started, but we're going in several different directions now because this product is highly dynamic, can be used in many different functions and fashions. So the project that we're talking about today is Skipjack Solar. This is a solar farm that was being built in Charles City, Virginia. It was built on a former working timber farm. Really what they were looking at here is creating a duct bank to feed the solar energy coming from the panels back into the grid. The duct bank itself was about 4,500 feet long, and obviously had to transmit quite a bit of power. So big challenges being that it was a quarter of a mile long, and they needed to do it in one continuous pull to pull to those pole risers and feed it back into the grid. So after it was pulled through the duct bank, it needed to go up via the pole risers that we ended up supplying to the poles back in the grid. Like I said prior, we're talking about a 4,500 foot long duct bank in a continuous run long pole to those new H structures.
So 4,500 foot pole in one pole is a pretty big deal, right? So that means you're going to have some coefficient of friction challenges there. Wouldn't you say, Matt?
Absolutely, Mike. It's one of the main considerations as to why people look at using fiberglass. When using a PVC jacketed cable with fiberglass, our coefficient of friction, or RTRC's coefficient of friction, is 0.38. That's versus a 0.55 for steel conduit and a 0.90 for PVC. So the ability to pull further in fiberglass is definitely there due to the nature of our very low coefficient of friction. So talking about the challenges here, there were some items that were already built, obviously on the complex, that needed to be navigated around. You have project lengths. They were requiring concrete encased duct banks. And then, of course, you have the fact that this happened right during the COVID-19 pandemic. And for anybody working in the utility space, EPC space, anybody dealing with electrical components, manufacturing or construction at that time, you know how difficult it was to source materials. So the EPC on site, Booth and Associates, who we had worked with before, really looked at us as an option due to the fact that they have had good luck with our deliveries in the past. So as far as how we managed to really nail this project, if you will, a lot of our features and benefits came into play. Fiberglass conduit actually has 100 degrees of temperature change on either side of PVC. And as most of you may know, PVC has been used for duct banks for many, many years now. And what we hope you take away from this today is fiberglass is a viable option for duct banks. So getting back to the temperature range, we go up to positive 250 degrees Fahrenheit down to negative 60. I don't know if you know this, Mike, but PVC's usable range is positive 40 up to positive 150. So it makes our conduit very, very attractive to use in areas of high heat, which of course includes concrete duct banks, as the concrete does create quite a bit of heat when it's setting. Cables create heat, the sun creates heat, so it means that we're a great option for duct bank and solar jobs for that matter.
That's interesting, Matt, because a lot of times we will look at the thermal resistivity of the soil and try to determine what kind of fluidized thermal backfill, if any, that we'd put into a duct bank, especially when we get into any kind of transmission. And I don't know that engineers, I don't think I ever stopped to think about what is the capacity of the conduit itself. I probably just thought that was a given. So there's something that an engineer ought to start to think about, especially somebody on the standards committee or in the standards group that is starting to say, okay, now what do we really need? And if we're legitimately having a conversation about ampacity and the heats that ampacity generate, we should be thinking about what kind of conduit that we've got as well. Interesting point, Matt.
Yeah, to your point, Mike, a lot of times when we're out talking with engineers, specifically engineers that deal with conduit that's exposed to the sun or an over roof, you look at the photo here and you see that a lot of our conduit is indeed black. And there's concern that, black attracts sun and heat, and the rate of thermal dissipation wouldn't work all that well. But in fact, what ends up happening with our conduit is our heat dissipation is indeed considerably better than PVC. So it definitely is a positive to using our conduit. Another thing to consider too, in talking about procurement, and I'll talk about this in the project solutions, is we were actually able to deliver this conduit in 6 to 8 weeks. This was when it was extremely difficult to get PVC. We're talking 16, 20, 24 weeks, and we pumped out an incredible amount of conduit in a short period of time. That's something that we pride ourselves as a company on, is being able to deliver large quantities of material in a quick amount of time. Additionally, when you're talking about installation, Mike, are you familiar with the NECA manual of labor units at all, or have you did you use that in your estimation when you were working for utilities or Burns and Mac?
I did not personally. I know at Burns and Mac we were EPC contractors, and I don't know where our estimators came up with their numbers. I've heard of is it the Dodge reports, but I don't think I've listened. I'm not familiar with the other now.
So the NECA values, National Electrical Contractors Association. They have their members, do time studies and then supply a ton of different information on how long it really takes a contractor to install absolutely anything. We, in reflecting upon the values in the NECA manual, looking at every different type of conduit under the sun, really have realized, due to those time studies, how much faster it is to install fiberglass conduit versus many other different types of materials. So I believe the rule of thumb for NECA is installing at chest height. They talk about the amount of man hours to install at chest height per 100 feet. And at 4 inches for fiberglass versus Schedule 40 PVC, we're about half the time to install. So you translate it to duct bank work, which of course is a lot easier to install down in a trench rather than holding something at chest height. That really ramps up your production time, being able to put the conduits together.
And that's just based on, Matt, that's based on the weight difference between the PVC, the fiberglass, or the steel.
Yeah, it's kind of wild to think about. So take 4-inch conduit, for instance. If you take a piece of 4-inch Schedule 40, 20 foot long, it weighs around 48 pounds a stick, whereas fiberglass conduit for a 20 foot long 4-inch piece weighs 14 pounds. Steel, you're probably looking at, somewhere well up into the hundreds of pounds.
Right.
In fact, I know off the top of my head, 100 feet 4-inch steel conduit weighs 982 pounds. So, there's even a weight savings to be gleaned here with our conduit versus PVC. And PVC, of course, is considered very light in comparison to most conduits. So, yeah, that weight plays a huge factor in it, Mike. One other thing that is different about RTRC is our conduit has what's called an interference gasketed connection. So the folks who are creating duct bank, rather than having to use any adhesive to put the conduit together, we're actually able to affix the conduit together, which is, of course, a UL-approved joint that's watertight and concrete tight, literally by using wood block and a hammer. It's similar to the way you would install water pipe with a gasket, if that makes sense. So you're not dealing with any epoxy down in the trench or PVC adhesive that might spill. It's less SDSs, less things to worry about going into the ground or getting on yourself while you're in the trench. So
not only is it lighter, it's significantly lighter and easier for a man or a crew member to handle, but now you get down to the hole and you don't have epoxy to deal with or any kind of primer or epoxy. It's a punch and stick type of thing.
Absolutely. Yeah. So when you're talking about multi-position duct banks, which of course are really common at, power plants, solar farms, data centers, anything like that, if you have the ability to just go and hit together sequentially, a multi-position duct bank, it saves you a ton of time. In addition to that, Mike, one other consideration is there are a lot of people that have used fiberglass in prefabricated duct banks, and the weight reduction allows them to put two 20-foot sections together, making 40-foot sections in multi-position duct banks. And it's a lot easier to just guide or slide it into the trench rather than having to put, together really just 20-foot sections into duct spacers like you would with PVC. So that's a huge benefit from a prefabrication standpoint for EPC contractors that have large prefabrication shops now. So something to consider there, that's for sure. One other thing I will mention too about the weight, because I think this figure is pretty startling. There are numerous contractors that we see that will send us photos of themselves, carrying 80 feet of fiberglass on their shoulders. They can put two 20-foot sticks together and have 40 feet on one shoulder, 40 feet on the other. If you do the math in your head, that weighs 56 pounds. That's that itself is going to weigh 54 pounds. I did that math wrong. That itself is going to weigh actually 6 pounds more than a 20-foot stick of PVC. So if you think about that, you can carry essentially 4 times as much into a duct bank or wherever you need it versus the PVC that you'd be using.
Yeah, I'm thinking about production efficiency. I also think about safety, crew safety as well. The other thing I'm thinking about, Matt, is that there's a number of utilities. I was glancing at some of the utilities that are listening to us right now that have got big underground programs going on. I know some of the challenges are, it's like when PG&E comes out and says we're going to build, $15 to $30 billion of underground, and we're going to get 10% of our system undergrounded, and we got to get it all done as fast as possible. This is going to help these utilities that have made these big underground initiatives central to what they're doing with their regulators, what they're doing with their customers and other stakeholders. And this will actually help utilities move faster, get higher production in some of the construction parts of their big underground programs. So I think that'd be a really important thing for engineers and planners to think about.
Yeah, you're 100%, Mike. And for utilities, whether it be below grade or above grade, even thinking about those pole risers that were obviously used on this job shown in the previous slides, fiberglass, just from jump, our regular epoxy conduit is low smoke, zero halogen. So areas that have high rates of wildfires, you really don't want to be using PVC because, of course, that would off-gas toxic halogens. You've got chlorinated and brominated resin in it versus our fiberglass conduit, RTRC, which has epoxy resin in it. So it's a great option above grade for utilities that are trying to accomplish high rates of wildfire mitigation. And like you say, below grade, you've got a low coefficient of friction, so much so that, if you have long runs, you can potentially eliminate the amount of pull points that you have due to the fact that your pulling tension is going to be much lower. pulling through those bends. Our fiberglass elbows don't burn through, unlike PVC elbows do, nor are they so heavy, and they don't need to be taped with non-corrosive tape like you would with a steel sweep. So when you're thinking about purchasing, a high quality EPR cable or really any other iteration of underground utility cabling, you really want to use conduit system, a lubricant, a puller, all of the proper installation techniques and materials to respect that cable as much as you do, because of course utilities are building grids that want to stand the test of time. So by using something like fiberglass, you're really keeping the stress off of the wire during those initial installations. And, I think the coolest thing about the conduit itself is that it's fault resistant too. We've been tested by TXU Energy and had numerous real world faults in our conduit. And if a cable faults in PVC, it's going to melt to the side of the conduit. Same with a metallic conduit, it's actually going to weld to the inside. Whereas using fiberglass, especially in duct banks, there's the potential to have less empty conduits or blanks in case there is a cable fault, because that run can actually be reconductored. So, there's so many significant benefits to utilities as far as the features and benefits go. Long-term for grid hardening, system hardening, grid longevity. But then, of course, on the front end with the install, there's numerous benefits to getting the projects done quickly. And of course, everybody wants to get everything done very quickly. So this product is excellent at meeting those goals. So let's talk a little bit about the project results. Clearly we are doing a webinar on this project, so it's a success. But of course, most of the projects that we're doing are successes because we're working with really talented EPCs and engineers on the projects that we do. So, they ended up getting a highly durable, corrosion-resistant conduit system that could handle the load that was on that project, and that's why we're selected a lot of the times for power plants, for solar farms, for wind farms, things of that nature, and data centers, areas that have a high degree of power draw. We talked about COVID-19 being around that time, but I don't want to discount the fact that we can get out product very quickly right now as well. So the product ended up coming in half the time versus the PVC that they were looking at. And of course, they got all of the features and benefits too. So at the time, and still now, there's definitely some cost competitiveness against PVC Schedule 40, which benefited the initial project budget due to controlling that material purchase price. But when you're able to install things a lot faster, that's going to reduce the overall labor costs, because it's going to reduce the amount of time that one is on the job. And naturally, too, the contractor was very happy because they could get the conduit in quickly, meet the deadline, get that solar field operational in a quick amount of time, and get that energy back on the grid. And then, of course, not to toot our own horn, but we provided them with excellent customer service. We're lucky, being a family-owned company, we still operate in a family environment where you can talk to any expert or any sales employee with ease.
Well, customer service is always a part of any kind of product. Invariably, something happens with delivery or specifications or things like that, you've got to have people that you can rely on. So it's all what I've learned in 40 plus years in the industry is that you're a team. So your vendors and your manufacturers, just like the other people that you have on your team at work, at the utility or at the AE firm that you work at, you're all a team getting the project done. So, customer service is something definitely to take a look at.
Yeah, absolutely. One other thing that I didn't mention, and it's an aspect of why we're used above grade, outside in areas of high rates of UV, solar farms, things of that nature, is the product itself has a UV inhibitor in it as well. So if you combine that with 100 degrees of temperature range over, PVC conduit with the UV inhibitor in it, it means that you're getting a conduit that will hold up extremely well in areas with, like I say, high degrees of UV degradation. It's why we're used in areas near the tropics or the equator, or of course in the southern United States too, because it holds up even in very, very harsh environments, whether they be extremely cold, wet, corrosive, or sunny. So probably why you specified it for TEP back in the day, even though it's under a bridge, it's quite hot there, and perhaps some sun would have hit it, right?
Actually, UV degradation was something that we definitely were thinking about and always cognizant of in the deserts of southern Arizona. We got a couple of questions here, Matt, from the audience. I think now is maybe a good time to throw them in just for the fun of it. And they're talking about, I think we've actually answered some of these things with regard to faults in fiberglass conduits and such, but people are asking about Schedule 80 PVC or high-density polyethylene, HDPE conduits, and how does that compare with fiberglass? And then they're also saying, if I have a transition from fiberglass to PVC or steel or, a different kind of conduit, what kind of transition couplings do you have at Champion that would be used for transitioning from fiberglass to another material?
Yeah, so I'll start with the transition question. The conduit itself, with the exception of one type of conduit that we make, is iron pipe size. So, another really hidden benefit of the conduit is the OD is going to be the same as the OD of PVC or steel or whatever they need to transition to, but the ID is larger. So you're going to get better cable fill rates, and therefore it will be easier to pull through for that matter because you're going to have greater deal of space. With that, we make a number of different transition couplings. One common way, or probably the most common way, our elbows are ordered, Mike, by contractors, utilities, is one of two ways. They order them with two deep socket PVC couplings that we actually bond on at the factory, which allows them to easily transition in and out of PVC. Or perhaps it's one deep socket coupling and one PVC stub at the other end, if they're coupling into a straight run and then going up into perhaps like a PVC polarizer. If they're coupling to HDPE, we make couplings that fit that size of conduit as well. So it really doesn't matter what type of conduit they're using. We make numerous types of transition couplings, including, of course, for DB conduit up in Canada as well. So lots of different ways to transition between the two. What was the other question that you asked?
Actually, I think you covered it. I think because they were talking about faults in conduits and what would happen. And I think you talked about how PVC would melt and steel. You would actually, the cable could potentially get welded to the side of the steel, but in fiberglass, you were able to be fault resistant.
Yeah, and I remember the second piece now. It was asking about us versus Schedule 80 as well.
Oh, Schedule 80, yes.
Yeah, so when you think about fiberglass conduit, there's really four different wall thicknesses. There's a standard wall, a medium wall, a heavy wall, and an extra heavy wall. Per the code, if you go into the NEC code book, if you're an electrical contractor, you will see that in the code for areas subject to physical damage, as well as Class 1 Division 2 use, that extra heavy wall conduit is what is to be used in those situations. That's commonly what's in underbridge jobs and was created really for protecting fiber optic cables in the late 80s coming into a major metro. So that's 1/4 of an inch thick. It's highly impact and compression, or it has a high degree of compression resistance and high impact resistance. Now, going back to things like a Schedule 80, depending upon what you need that Schedule 80 for, the extra heavy wall may make sense for that. Otherwise, our heavy wall may make sense for that. Generally, if you're crossing between fiberglass and Schedule 40, the standard wall is more than sufficient. The rate of compression is slightly better than Schedule 40, and the impact resistance is significantly better. To give you an example, fiberglass, because it's a filament wound product, and it's wound, in one direction and winds back in the opposite direction, we've really got this nice crosshatch pattern. When you compress fiberglass conduit, it may go ovate after an extreme amount of pressure, but when that pressure is released, it bounces back into that cylindrical shape that it came with prior. So it's not going to shatter like PVC, nor would it kink like a metallic conduit. So does that kind of flesh out the differences between us and?
Yeah, I think you did a good job doing that. Let me take this a little bit further too. So as engineers that are specifying various conduits for my underground systems, there's the National Electric Safety Code, which I would think of if I'm in California or Hawaii. I've got general orders that I might be applying. But it sounds like to me, Matt, that maybe I should be looking at the National Electric Code, the NEC. That's just something that I would think normally that I'd find on a commercial or industrial site. And then you can comment on that. But then I would also ask, are there IEEE standards? Or are there ASTM standards that I should be well aware of for fiberglass in particular?
Yeah, we have a pile of engineering information that we supply to our engineers and customers, so they can essentially translate between the code requirements for each. What we find with utilities is they may lean off of the engineering information or ASTM testing that we've done, the UL listing requirements that we, of course, meet with our product, and then cross-reference it with the NEC. And what we end up finding is that it's really a blend of the two because, of course, utilities craft specifications based off of their specific needs. So sometimes the wall thicknesses tend to be a little bit thicker than a standard wall and are closer to a medium or a heavy wall for specific areas of need. Say it's regular underground direct burial distribution, or maybe they're more similar to the National Electric Code. But we at Champion, pride ourselves on being able to really dig deep in those codes and look at what a customer needs, and then recommend product based on what their specific needs are. So it's really a pick the right hammer situation, Mike. It's far less of a super salad question, but it seems to work well. Got a lot of dedicated utility specs and municipal specs for that reason that have been crafted over the years. So
good. Okay. Thank you. Well, let's get back to this Skipjack project. I've got a couple of other questions, but let's go ahead and learn more about this project.
Yeah. Yeah. A couple other things that I will say as well about this project is I want to go back a little bit to the temperature range and derating because I don't want to discount the value of our conduit. A lot of times, due to the fact that thermal dissipation is better with fiberglass than other conduits, engineers commonly come to us after looking through the engineering information and notice that they don't have to derate conduits for that reason due to the rates of thermal dissipation as well as that larger interior space that I was talking about. So that, of course, is a consideration above grade, but plays into spacing and into concrete duct banks as well for below grade applications. Additionally, we have a low coefficient of friction, like I said before, and with the utilities that we work with, normally we're hearing, their pull points are about every 600 feet. We have numerous utilities, including folks that we're talking with right now that are able to retool their specs to lengthen the length of allowable runs due to the use of fiberglass as well. So both of those key components played a factor in the successes of this project. So just a couple things to note on that.
Yeah, I don't think we should let that go by very, very quickly. I think it's really important. If you can lengthen your runs, that's a big deal, and you're saving a lot of money for your company if you're doing it. And yeah, you're going to have to prove it, but it sounds like you guys at Champion have got all the backup, all the customer service and such to help an engineer or a planner prove it. But if you can stretch out runs from a standard 600 foot between manholes or pulling locations to 1,000 or more, that's a big deal.
Oh yeah, absolutely. Now, one other question that I do want to answer that I'm seeing pop up a couple different times is folks are asking about how this compares to HDPE conduit. And really what I would say is our conduit doesn't come in rolls. We're coming in straight sticks, 10 or 20 foot lengths. Most of the time people are using those 20 foot lengths due to the fact that they don't have to join as many of them together. It's half the joints, of course, as using 10s. HDPE is, of course, a great product as it can be directionally drilled, but we're going to maintain a straighter direction than HDPE because, of course, directionally drilling isn't always straight. And HDPE does indeed have a memory where it wants to coil up like it was on the reel. So we have the ability to be forcibly flexed quite a bit in the field. RTRC, a 4-inch by 20-foot long stick, can be forcibly flexed about 26.5 degrees over that 20-foot stick. I always find that people are really surprised by that figure because when you pick it up, it's really straight as an arrow. There's a lot of rigidity to it, but it can be kicked if necessary. As we all know, duct banks aren't always straight, so that's something to consider. But yeah, significant differences between HDPE and fiberglass, but there's features and benefits to using both as well.
That was one of the questions, Matt. Thanks for answering that. I will say to the audience, if you've got any further questions, keep them coming for Matt Fredericks from Champion Fiberglass, and we've got some more to share here about this Skipjack project, but keep your questions coming.
Yeah, one other thing that I will also mention about fiberglass is it can be field bent as well. A lot of people, like using HDPE or PVC because it's a malleable product. But fiberglass can actually be bent using a hot box and a one-shot bender. We actually have videos of that on our website that shows how RTRC can be bent in the field. So that is something that's quite nice if somebody needs to make a quick bend or an offset in the field. It can be done. It's not cumbersome at all. Just requires a hot box and a bending shoe, like I said. So one thing I do also want to mention as well, you know, a lot of folks when they're talking about duct banks too are using, let's say like a EB10 or an EB20. One consideration for why they would want to use something like fiberglass versus those types of conduits would be that wall thickness, especially if you're making turns, the ability to, maintain shape, not go ovate, hold up under, significant degrees of sidewall pressure, pulling tension. We've got a thinner wall similar to what folks use when using EB conduit, but we're going to be a lot more robust. In fact, like I said before, more robust than the Schedule 40 conduit. So that's what we had on Skipjack. Are there any other questions that we can answer? Ooh, I'm seeing one that I really like right now. Somebody asked from the audience, does our product meet Buy America requirements? It absolutely does. In fact, our product is very unique because we meet BABA, and when you look at our product itself, we are getting our materials actually, primarily from the state that we manufacture in, which is Texas. Being that we're the chemical capital of the world, we've got a lot of resin and hardener manufacturers in our state. So yeah, we are fully Buy America, Build American compliant, all U.S. made with U.S. materials and made right at our facility in Spring, Texas. So excellent question and something that we do extremely well with.
Good. I had a question for you too about the types of customers that you have. So you've got your traditional utility, whether it's public power or co-op or investor owned, but are you seeing more and more work coming from developers that are building out things like what AES did here with the solar farm? I don't know if AES was your customer or if your EPC contractor was your customer. And then are you seeing other kinds of customers that are building data centers or other types of non-traditional customers?
Oh, yeah, absolutely, Mike. Yeah, it definitely on the renewable side, with solar and wind, so many of those projects are popping up all over North America. And fiberglass is getting more of a look now due to the successes that the EPC contractors have had on your traditional commercial industrial type of jobs and applying it to numerous different renewable energy generation jobs that they have. Additionally, you talk about data centers. Data centers and AI are just exploding around the United States right now. And the demand for getting information quickly, artificial intelligence, data storage, what have you, is massive. So being that those types of facilities have large power requirements, large power demands, we definitely supply a significant volume of product to those types of facilities. And what we find is that as we have success with certain projects with engineers or even the end users themselves, you start playing connect the dots, if you will, with many, many different types of projects across the states and across Canada in that fashion. So yeah, heavy areas of or heavy projects with heavy power draw is significant. too, with that, Mike, the types of conduit that we supply, we can make 3/4 up through 12-inch. And I'd be curious to know in your engineering days, whether it be with Burns and Mac or the power companies that you've worked with, we see more and more RFPs or project requirements calling for a lot more 8 and 10-inch conduit. To me, that's a huge indicator that the power demands are getting bigger, but it seems like those requests are really significant these days. So was that something that you ran into when you were engineering for power companies or Burns and Mac, or is that something?
Yeah, I think Burns and Mac might have seen some 8 and 10-inch, but that was going for like a 69 or maybe 138 kV underground system. So typically that would, back when I was doing it, I would think 5 or 6-inch conduits, because we were doing underground feeders out of substations. So
Yeah.
that was my previous experience. Okay, I got a question here from the audience, Matt, that I think is interesting. They're talking about Schedule 40 PVC encased in concrete, as opposed to maybe using Schedule 20 or even Schedule 10 if it was encased in concrete. So talk about concrete encasement for the various schedules of PVC versus concrete encasement or none for the PVC.
For sure. So concrete encasement with PVC, whether it be 10, 20, or 40 versus fiberglass, generally when you're concrete encasing PVC, as that question points out, it's generally done with those thinner types of conduit. With that, you're still having to more than likely glue those sections together. With fiberglass, specifically with this project, what the EPC leveraged was using our gasketed interference joint, which they didn't have to use any epoxy. It was concrete tight and watertight. We actually have a specific joint type. That one that I just mentioned is good for concrete encasement and direct aerial, but we have a joint type called the interference joint type. You can watch videos of it being put together on our website. It's extremely cool, Mike. It's got a CNC'd end on the male end, and it's got rings that are molded in during the winding process on the female end. And when those two conduits are put together the same fashion as the interference joint, that is concrete tight joint as well. And it's a little bit less involved to put together than the gasketed joint, even though that really takes no effort at all. This one is just a hair easier to put together. So when you're talking about the two, certainly Schedule 20 or 10 may be, quite inexpensive as far as purchase price goes. But the weight is going to be similar to our fiberglass conduit, and our fiberglass conduit is far better at handling the heat and retaining the shape under those conditions, if that makes sense.
Yeah, so here's another question from the audience related to heat, and it's on HV and EHV transmission applications. So I think I'll preface this by saying, do you see, we mentioned the 8 to 10-inch conduits, which would typically be used for maybe a transmission voltage. Are you seeing more demand for those larger conduits, for those larger cables that would make up maybe a higher voltage, even transmission or sub-transmission cable systems? And then speak a little bit more about the heat of that's generated and how that's dissipated through the fiberglass and then through the soil with the thermal resistivities of the soil. It's a long question, but the person that asked this question didn't ask it that long. I kind of got a little long on that question, but talk about the larger conduits and transmission and heat, if you would, please.
Yeah. We are seeing that type of demand increase very significantly, Mike. there's a lot more transmission that's going underground now. Most people are used to seeing, large H structures or giant high tension power lines now, but as we know, there's even substations that are underground now. So there's a huge effort to strategically underground, and that it does apply to transmission cables, and therefore we are seeing the demand of 8 and 10-inch increase quite a bit. Of course, our rate of heat dissipation or heat transfer coefficients is better than PVC. I want to say it's roughly about 20% better if I'm remembering the table correctly. So that's pretty significant when you're talking about putting cable in a conduit underground and having that 20% better savings, if you will. Additionally, when you're looking at pulling cable that large, the cable is extremely heavy. It doesn't bend as easily. And with fiberglass, you're able to make large sweeping bends that hold their shape below grade that can be put together without the use of adhesive. We often reflect on a photo that we have of one of our employees holding an 8-inch by 90 degree by 96-inch radius 8-inch elbow. And we talk about this a lot when we're doing lunch and learns. And that elbow itself weighs in a low 30-pound range. The equivalent in PVC and steel would be astronomically higher. So, it's easier for the contractors to get in the ground. It's easier to put the cable in. And then, of course, it's easier for the cable to survive in with that larger interior space and the heat transfer coefficients being significantly better than PVC, which is what they're generally using for below-grade applications.
I'm glad you mentioned lunch and learns. I think lunch and learns and webinars like this are very important for young engineers in particular to learn about things that are actually changing in our industry. This is a big change. I've always thought that emerging technologies are based on material science in many cases, and this would be a perfect example of that. And you today, I think, Matt, have talked about a lot of the attributes of fiberglass conduit and a lot of the reasons why I, as an engineer, ought to, at a minimum, be specifying this at least consistent with, if I'm using PVC conduit, I should at a minimum have this side by side to it. So when you go to utilities, are you finding that young men and women, engineers of the future, engineers are embracing this kind of conversation, or are they eager to hear more about the kinds of things they can do to enhance the value that they deliver to the companies they work for?
100%. I will say, for better or for worse, I think the supply chain issues that we had a couple years ago really opened a lot of people's eyes to a lot of different products that are on the market and new technologies. And that doesn't just apply to our own. And I think there's a lot more openness now due to those supply chain constraints where people are looking at things differently. And it's allowed us to go into those spaces that, perhaps have had specs that have been held in the same fashion for a long time. Have people reflect on this as a new opportunity to do things differently, to reduce costs, reduce labor, offer a safer product for linemen and women to use, and then offer them a ton of different features and benefits that they hadn't gleaned from the existing product that they're currently using. I think getting back to the original statement that you were talking about at the beginning of the presentation about specifying this for underbridge use nearly 40 years ago. And what we're finding is that this product can be used in so many different fashions now. In the industry itself, including the utility industry, is really embracing it with open arms, and they're having a lot of successes with it. But that just goes to show you that I think there's a general openness in the industry for these new problem-solving products Again, not just ours. There's plenty of awesome new technologies out there. But this is one that I think is really a positive disruptor in the industry right now and causing people to think differently about processes and products that they're currently using.
And they should. I think you've done a really good job explaining that today, and I think we've had some great questions from the audience. I'm going to ask you one more question. You said something about underground substations, and when we were at the IEEE, we got to go see Anaheim's underground substation that they've built, and I'm aware of one other that's going in. Eversource Energy is going to build an underground 345 kV substation in downtown Boston, which I think is incredibly cool. Yeah. So what do you know? Overseas underground substations are not a big deal. Are you hearing of any others here domestically in the North American part of the market?
When we've been talking to engineers and utilities, it's definitely a topic of conversation right now. I think there again, people are looking at how other countries and how other utilities are really sort of flipping the old ways on their heads. So it's funny you bring up Anaheim, because I think that site visit and the publicity that came from that site visit, because I saw it all over the place after that happened, that it has really sparked a lot of conversation for utilities to really rethink how they do substations and how they can be looked at differently. So yeah, good question, Mike, and the excitement is definitely there right now.
Yeah, I agree. I look forward to watching Eversource and what they do there. So Matt Frederick's great presentation of a technology, a product built around technology that we should all be aware of. I would encourage engineers to seriously look at this and make sure that your standards group has got this in the specifications, and you can help foster that. You can not to use the word champion in a funny way here for champion fiberglass, but I mean, you're always looking for an internal champion in companies to find something like this and say, okay, I'm going to make sure that my company is going to get the value out of this. So anyway, well done today. Thank you to the audience for the questions. Matt, why don't you give us some concluding remarks and thank you.
Yeah, absolutely. Thank you guys all for joining in and listening. If you have any additional questions, we would love to speak with you. I believe you can see my email online. Otherwise, please feel free to visit our website at championfiberglass.com. We have a wealth of resources, calculators, videos, case studies. And like Mike said, I would encourage you guys to take a second look at fiberglass. It may not be something that you've ever heard about before, or may just use in specific situations, but I would venture a guess that there's significant cost savings, labor savings, and features and advantages that you haven't thought about in a while that really could be leveraged through this really cool product. So again, thank you all so much for attending. We really look forward to speaking with all of you soon.
Yeah, well done, Matt. And we appreciate you being part of the Power Delivery Intelligence Initiative. And PDI Squared, as we like to refer to ourselves, is out there to bring these kinds of resources to you. You can go to our website at pdi2.org and learn more. And there's all sorts of rich resources there to help planners and engineers, and I like to say even data scientists these days, to do their jobs better as you're evaluating the total cost of ownership of underground versus overhead over the life of the asset. So with that said, on behalf of the Power Delivery Intelligence Initiative and Champion Fiberglass, this is Mike Beeler saying thank you very much for listening in. And Nikki Chandler at T&D World, back to you.
Thanks so much, Mike and Matt. This has been a very interesting discussion, a lot to digest and consider and follow up on, it for sure. But that does conclude the presentation today. And on behalf of T&D World, I'd like to thank PDI Squared and Champion Fiberglass for sponsoring the webinar, and of course, all of you for joining. Have a great rest of your day.